Hashing is used to prove that a message has not been corrupted or changed during transmission. However, to prove that the message originated from a trusted entity, digital signatures were introduced, which prove that the sender is who he claims to be. When an entity wants to send a message to a second entity, they have to generate a message digest or hash of the plain text, then encrypt this hash value using their private key. This encrypted hash value is what is referred to as the digital signature. This hash is then appended to the plain text message, and together are encrypted using the second entity's public key. Once the message is received, the second entity can decrypt the message using their private key, then use the public key of the first entity to decrypt the hash value. The second entity then computes the hash of the plain text message and compares it to the hash value decrypted. If the value is the same, then the message has most probably not been altered and it was sent by the first entity. Therefore, digital signatures ensures the integrity and non-repudiation of the data. Algorithms that should be noted in relation to digital signatures include the hashed message authentication code, the digital signature algorithm, the Rivest-Shamir and Adelman, and the elliptic curve algorithm. One of the major benefits of public key encryption is the possibility of having a trusted communication between two entities that have no prior trust relationships, and this is made possible through the public key infrastructure. Digital certificates are the main part of the system, which assure the identities of the communicating entities. Digital certificates are copies of the entity's public keys, with the exception that they have been verified and endorsed by trusted certificate authorities. The construction of a digital certificate is governed by the X.509 standard, which demands certain data to be present including, the serial number of the certificate issued by its creator, the signature algorithm identifier, the issuer name which is the authority, the validity period, and the entity's name and their public key. It is worth noting that this standard has not been officially enforced, but it is widely used. The certification authorities are neutral organizations that offer digital certificate services. The major authorities include Symantec, GoDaddy, GlobalSign, and Comodo. The trust given to a certificate is directly related to the trust of the issuing authority, so a minor virtually unknown authority doesn't have the same credibility of the major ones. Usually browsers are pre-configured to trust the major authorities, so all certificates trusted by those authorities are automatically trusted by the browsers. Registration authorities assist certification authorities in verifying the identities of the users before issuing them certificates. To obtain a certificate, a user must prove his identity to the authority, which is called the enrollment process. Upon verification, the user provides his public key to the authority, who then creates the digital certificate, and signs it using their own private key. Received certificates can then be verified using the authority's public key, and by ensuring that a certificate is not on a revocation list.